Okay, ladies, significance tests. Here we go. So I'm going to show you how to do this with all the math using some specific examples to make life a little easier. So because we're learning how to do carrying out tests for the first time, we're going to start it the same way we did with confidence intervals. We're going to start with proportions and then we'll do means later. So today is all about proportions. You're really already familiar with all the parts you need to compute this test. We've actually talked about hypotheses. You know exactly how to write them. And you actually know the conditions from the previous chapter. So our conditions, random, independent, large counts, exact same as they were for proportions before. So it should be fairly familiar. So let's go ahead and get started. So this particular inference method is called a one sample z-test for a proportion. So that is the name of our inference method. And the test statistic really compares our sample data with the null. So if the values of the test statistic are far from the null in the direction specified in the alternate, it provides strong evidence against the null. So what that means, if I find a value of my test statistic that is way far away here and I have a really tiny p-value, then there's no way that the null is going to be true. And this is kind of how we write this, and you're going to see this form a lot. So this is saying that the alternate hypothesis is p is greater than this p sub 0. And this looks familiar because that's how h sub 0 is how we wrote the null. So this is, when we say this, we say we think the true proportion is greater than the p null. That's right, you heard me right. So the p null is the proportion that's stated in the null hypothesis. So this would be, we think our proportion is greater than our p null, which means we're looking for this particular probability. This one, we think that the true proportion is going to be less than what's stated in the null. We're going to be looking for this area right here. And then if we're looking for our p is different from our p null, we're going to be looking on both sides. And if you look, oh, it's just a z-score. So really, we're just calculating z-scores and probability that we have something that is that far away or more extreme than the value that we actually got, so that we can say, oh, if it's a really small value, this has evidence against the null. So to determine how far our statistic is from our parameter, we're going to go ahead and standardize our statistic. So that would be the test statistic that we know and love. Statistic minus parameter divided by standard deviation of the statistic. And this really measures how far our sample statistic is from what we would expect if the null were true. Because we are dealing with proportions, and because I've already told you it's a one sample z-test, you know that our test statistic is going to be our z-score. So that is what we're going to be working with. So let's talk through a four-step process problem. So here is the problem. On shows like American Idol, contestants often wonder if there's an advantage to performing last. To investigate this, a random sample of 600 American Idol's fans is selected to view the audition tapes of 12 never-before-seen contestants. For each fan, the order of the 12 videos is randomly determined. Thus, if the order of performance doesn't matter, we would expect approximately 1 out of 12 of the fans to prefer the last contestant they view. In this study, 59 of the 600 fans preferred the last contestant they viewed. Do these data provide convincing evidence that there's an advantage to going last? Let's find out. So, state plan do conclude. You know it. Here it is. So when we're doing our state, we want to talk about what hypotheses you would want to test and at what significance level, and you need to define the parameters that you use. So one more time, step 1 of the state, list your hypotheses. Step 2, mention at what significance level you're going to compare your p-value to. And 3, you have to define the parameters you use. So we want to test the following hypotheses at the alpha equals 0.05 significance level. This is a standard part of how we're going to start these. then we can actually use notation. So we can say, okay, our P null is our true proportion we think is 1/12, and our alternate we think is greater than 1/12. Now this is fine as long as you then define your parameter, where P is the true proportion of American Idol fans who prefer the last performance that they see. Great. State done. Now we're going to move on to plan. Okay, so in plan, you need to choose the appropriate inference method and then check conditions. It's the same as it was before. So if conditions are met, we are going to perform a one sample z-test for proportions. Notice it's very similar, only you have this important word test instead of confidence interval. So one sample z-test for proportions and if conditions are met. So let's go ahead and check our conditions. So random. A random sample of American Idol fans was selected. The order in which the videos were viewed was randomized for each subject. Perfect. Okay, independence, 10% rule. It is reasonable to assume that there are at least 6,000 American Idol fans in the United States. Or, yeah, I think that's pretty reasonable. Okay, and then we're going to do our large counts. So to do our large counts, we're going to compare our, before we just had like one proportion, right? We just had what we thought the parameter was. And that's kind of the same thing here, only we need to use the P null. So we're going to say n times P null. So 600 times 1/12 is 50. That's greater than 10. And your n times your 1 minus your P null is 600 times 11/12. Right, equals 500 because this is 1 minus your P. So really this is called your number of successes and this is called your number of failures. So you have, you want to make sure that both are greater than 10 and you have it. All conditions are met. We can go ahead and proceed. Okay, so do. The sample proportion of fans who prefer the last contestant is P hat is equal to 59 divided by 600, so that's 0.098. And then we have our test statistic here, which is, if you'll notice here, we have P hat, right? And P null. Do not get them confused. So we're going to take our P hat value. Our P null value is 0.083 there, and that would be our that would be 1 divided by 12 in case you were wondering. So now I'm going to have my P null value right there times 1 minus P null divided by 600, and I get my z-score of 1.33. So then the p-value, the p is, we have a p-value of z is greater than 1.33. So if I use my calculator and do normal CDF, I would enter in 1.33, infinity, 0, 1. I get 0.0981. Now I can do this also here on my table. So looking at my table, I could come over here and again, this is my standard normal table, so z-scores. I'm going to look at this right here, negative 1.33. Again, I could look up 1.33, but I don't want to do the math. So I'm going to look this up and I'm going to see that it's 0.0918. So that's negative 1.33. That's going to be my p-value for my z-score. Again, like I said, you can look up 1.33. You would then just have to do the math and go 1 minus the value, and then that would give you your p-value. So now we're going to conclude. So when we get to the concluding part, again, we're comparing our p-value to our alpha. We have already done a conclude. This should be pretty straightforward. Since the p-value is greater than our alpha, and then we state that 0.0918 is greater than 0.05, we fail to reject the null hypothesis. There is not convincing evidence to conclude that there is an advantage to performing last in American Idol. Okay, ladies, so let's talk about how to do the same problem on the TI-89. So I'm going to show you on the calculator first for how we would do that. So in your calculator, I'm here in StatsList Editor. I'm going to go second, and then I'm going to press F1, and then that's going to lead me to F6. Ooh, tests, brand new. Notice it's not ints. tests. So then we're going to go down to one prop z-test, which is the name of our inference method, hit enter, and then I'm going to enter in my p-null value, which was 1/12. Now I can do that in, I believe I can do it in fraction form. I like decimals, so I'm going to do it in decimal form, 0.083. And then I'm going to do my number of successes, which in this case was given to us as 59. It's not always given to us, so when it's not given to you, you can take the 1/12, and then you would multiply that by 600, and that would be your number of successes. Remember that it has to be a whole number though, so round it to the nearest whole number. Okay, so now I'm going to go to n, my sample size, which was 600, enter that in. Again, both successes and n need to be whole numbers. So now I'm at the alternate hypothesis. It looks kind of weird. So we're going to arrow over and we're going to see our options. So I have prop is not equal to the p null. The prop is less than the p null. Oh, that's what we want. The proportion is greater than p null. In our case, p is greater than 1/12. There we go. That's the one we want. We're going to hit enter. I'm going to hit calculate. I can arrow over. You can see there's calculate and draw, but I'm going to choose calculate. So calculate gives me a p null value. There's my z-score. There's my p value, 0.08669. Pretty good, pretty similar. Again, it's slightly different because calculator versus rounding. But if you round it to 0.09, it's close enough. So that's a great way looking at calculate, but let me go back to the draw function so that you can see what that looks like. So if I go here to the draw function, so I'm going to arrow down until I get to calculate, arrow over, arrow down for draw, hit enter, and I have to wait patiently, and oh, there it is, beautiful normal distribution. And then it'll show me the shading. So I'll end up with my z-score and my p-value, there it is, so pretty, 0.08669. Again, which if we round is to 0.09, it's perfect. So what I usually do, it goes back and forth on what I feel like. In this particular inference method, I tend to use the draw function because I know I'm going to need to draw it anyway, and why not have the calculator draw it for me, and then I can do a rough sketch. Note though, if you're going to use calculator methods, you need to list, right? You need to list these three things: the p null, your successes, your total number of trials, and your significance level. So you have to have your alpha back here as well. And then you should be drawing a rough sketch. Look at how rough that is of what my p-value is. Oh, great. And just so that people know which way you're trying to find things. And then that's all we have for our do. So that's how we do it the long way. That's how we do the calculator, and we are done.